Boom, and we're live. Alright guys, what's up? Another mocking interview with Leetcode. We have like 40 minutes to do it, so that's gonna be a challenge. I have three options: online assessment, phone interview, or on-site interview. And we're gonna go for the honey, right? So let's start an on-site interview. 2 hours, 4 questions. We don't need that. We'll do it in 40 minutes. 3 questions, okay. Let's see. A self-dividing number is a number that is divisible by every digit it contains. For example, 128 is a self-dividing number. Yes, it is. Also, is not allowed to contain the digit 0. Because you can't divide by 0. Lower and upper, a list of every possible self-divide including the bounds if possible. Okay, so we are given a range and we should output each number in that range, each self-dividing number. Cool. We'll try out each number and we'll check if that is true by just dividing it by 10 and taking the last digit, right? So that's kind of basic stuff. Yeah. So what I'm gonna do here is that I'm gonna try out each number. I hope you can see. Let me just zoom in so you can better see the code. I think that's gonna be a good idea. Maybe like that. Alright, so I'm gonna take each number, right? So for each number starting from left, num less than or equal to right, num plus plus. For each number, I just need to output the numbers. Cool. So I'm gonna need a vector to store these numbers. So vector of integer. Should I do it like that? Yeah, self-dividing numbers. So that's quite a suggestive name. Self-dividing numbers. Right. So yeah, basically if is self-dividing of num. So if this number is self-dividing, I'm just gonna push it. Self-dividing numbers dot push back of num, right? Cool. Looks good. Now I need a boolean function. So bool is self-dividing, and I'll take the number. And what you're gonna do here, we are just trying out each digit. So first of all, we don't have to contain any 0. This is very important. We can't be 0 because left is at least 1, so that's good. I'm not gonna check for that. What I'm gonna do is that while this number is greater than 0, its last digit is going to be, so last digit is going to be num modulo 10. Now if this last digit is 0 and the number is not 0, then we have a problem, so we return false right away. And if not, then everything is fine, but we should check that this last digit is a divisor. So also, if not last digit or num modulo last digit is not equal to 0, then I return false. Alright, cool, everything's good. Yeah, one thing we should do is, I don't know exactly, it doesn't matter where. After checking this last digit, I'm gonna cut it off, right? So yeah, this is fine. Also, I don't need this, I can only check for this. So yeah, cool. And of course, if this is over and everything is fine, I'm going to return true at the end, right? And here I'm going to return the self-dividing numbers, right? So this was just kind of a warm-up problem. It should be fine. 1 2 3 4 5 6 7 8 9 11 12 15 21 22. Okay, that's not good. I have a 21. Yeah, that's not good. Oh, of course it's not good. Of course it's not good. Because I checked the number and I also modified the number, right? So we should be very careful. What we should do instead is make a copy, very important. So make a copy of the number, original number. And here we just need to check if the original number is indeed divided. Yeah, now everything should be fine. 11, 12, 15, 22. Yeah, should be right. Great. Next question. Next question, boys. Given an array of citations, each citation is a non-negative integer of a researcher, write a function to compute the researcher's H index. According to the definition of H index on Wikipedia, a scientist has index H if his, her, n papers have at least H citations each, and the other n minus H papers have no more than H citations each. So we are given the array of citations 30615, and the output is 3. The researcher has 5 papers in total, and each of them had received these citations. If H of his papers have at least H citations each, and the other one have no more than H. So the answer here is 3, because we have 3 numbers which are greater than or equal to 3, and the other numbers have no more than 3 citations. Alright, so we need to find the greater number H, such that there are H. Let's comment that. So, find the greatest H such that at least H if H of his, okay, such that, alright, H of the numbers in the array are greater than or equal to H, and the other n minus H have no more than H citations each, or less than or equal to H, basically. Okay. So for this array, 30615, the answer is 3, because we have 3 numbers greater than or equal to 3, and the other 2 numbers are less than or equal to 3. Okay, so I think we can see this better if if this would have been sorted. So if we sort this, then why is the answer 3? Well, every number on its right. So first of all, okay, I have a feeling that the answer, this H, is actually a part of the array. I think it's always part of the array, because why not? Because why not, right? Why would it not be a part of the array? Well, it doesn't matter. Yeah. it might not be part of the array. Let's see, the array is this 1, 4, 5, right? If this is the array, then the answer is 2, right? The answer equals 2 because we have two numbers greater than or equal to 2 and the other one number is less than or equal to it. Couldn't be 4. It could be 1. Could it be 1? If there are several possible values of h, the maximum one is taken as the h index. Okay, so it could be 1, but 2 is better. Could it be 3? It couldn't be 3. Yeah, alright. So the answer is not necessarily part of the array. But what I'm gonna fix is the h. Yeah. So because we need an h such that each of the numbers are greater than or equal to h, this h couldn't be greater than n, right? The number of elements. So h is for sure less than or equal to n. We know that for sure. So I'm gonna fix h. And if I know the h, let's see, like in this example, h equals 3. If h equals 3, and we are going to take a look at the greatest 3 numbers, and they should be greater than or equal to that value. Yeah. Okay. Okay, yeah, that makes sense. Yeah, so yeah. Okay, so I'm gonna try out each h and I'm gonna see if the greatest h numbers, all of them are greater than or equal to h, and the other numbers are less than or equal to h. Basically, that's it. And I'm gonna pick the greatest h that satisfies this. For example, here, if h equals 1, the greatest number is greater than or equal to h, but these two numbers are not both less than or equal to h, to 1. So 1 is not good. 1 is definitely not good. Okay, this statement is very weird. This statement is super weird, but yeah, very weird statement. Very, very poorly written statement. But anyways, you choose the h, you check if the greatest h are all of them greater than or equal to h, and the rest of them are smaller than or equal to h, something like that. If it's not this, the statement is definitely very poor written. And yeah, more examples should have been of help. So in this scenario, ask the interviewer for a lot of examples or stuff like that, because this statement is super, super bad. But yeah, let's sort the citations. After doing that, I just need to fix the h. H, of course, should be at most, yeah, could be at most the number of citations, right? So citations of size h could be at least 1. Not necessary. Not necessary. Probably h is greater than 0. H minus minus. But yeah, h equals 0 is pretty weird. How do you do an h equals 0? I guess you can. I guess you can, yeah. Alright, so I'm gonna take the greatest h citations. So this is citations. Okay, I'm gonna store a variable for the number of citations because this is how it's done. I use it many times. Citations of n minus h. No. If h equals 1, for example, I need the greatest. So it's n minus h. Yeah, it's n minus h. That is. Okay, I need to check if this one is greater than or equal to h. And also, the previous one should be less than or equal to h. Yeah. Less than or equal to h. Cool, and if this happens, then I just found the h. Yeah, that h is definitely valid. If that happens, that h is definitely valid. Alright, we need to be very careful at this h equals 0, because this can get very nasty. But if n is the size, then h starts from n, and if h is 0, I don't like this. I think h could always be 1. No, it couldn't. H could always be 1. It couldn't be 1. But if it's 0, how do you check the greatest 0? You don't. Yeah. We will go to 1. Check this. And if this is correct, we just found the greatest h. If this doesn't happen, then we return 0. We have no other way to do this. Very weird problem, man. A very weird problem. Yeah. There probably could be some... this could be empty, but if it is empty, I don't think it's any problem. And if it's not empty, if h is 1, yeah, I guess that's it. But the statement is very weird. I think it should be less than, not less than or equal there or something. Okay, last executed input is 1. So for only 1, it doesn't work. Interesting. If h equals 1, citations of... Oh, yeah, of course. Yeah, of course. Damn. Could have thought about it. So be very careful with this. You can get runtime error a lot, right? So h is equal to n. And I check n minus h minus 1. This is not good. If h is equal to n, I have to check that. So if I want h to be equal to n, what I have to do basically is that every one of them should be greater than or equal to n. Every one of them citations, right? So one way to do this is actually check here separately. Yeah, there are some ways to do that. Yeah, basically what I can do here is h equals n, or citations of that is less than or equal to h, right? So that's an idea, because if h equals n, I don't need to check this. Yeah, or you could have written it separately at the beginning, I don't know. Okay, and the output is 1, should be 1, right? Yeah. Yeah, the ugly, nasty question too. Alright, so the statement was very poorly written, because here you have greater than or equal in the first one, and in the second one, no more than h, so less than or equal. So what do you do if those equal? You take it into the first category or the second one. This is what bugged me, like all the problem. It's not hard. After you sort it, you can try out each h and just make this if, but yeah, it would have gone south. Alright, so I don't know, guys. Is everyone watching? What's up? Hey man, what's up? Everything's fine. I'm just doing a mocking interview and I thought I'd let you in. Alright, I have an crust and grid. 0 means that the cell is empty. 1 means that the cell contains a cherry. -1 blocks your way. Collect the maximum number of cherries possible by following rules. Starting position 0, 0, ending at position n -1 and -1 by moving right or down. After reaching, return to 0, 0. By moving left or up. Okay, so you basically start from 0, 0. You go to n -1 and -1, and then you come back to 0, 0. That's interesting. Okay, this is interesting. All right, so we basically have to start from the upper left corner, get to the bottom right corner, collect some cherries, and then move back in the upper left corner again, right? But the cherries don't exist anymore after the first part of the route. Cool. Think about it. Let us think about it. Okay. So it's definitely dynamic programming, right? In order to do the first part of the route, it's a classical DP. But when you come back, you can't take the cherries that were taken anymore, right? Interesting. How do you do that? Anybody has any idea? Anybody has any idea? I don't see him. No, you don't need premium to mock an interview. So how can we do this, guys? How can we start from there, go to there, and then return without taking those cherries again? One way to think about it is that, let's just do the optimal first part of the route, remove the cherries, and then apply the algorithm again for the second part of the route. But that won't work. It's not necessary that if we complete the first part optimally, remove the cherries, then also then complete the second part, that would be the optimal full path. It's not necessary. Can we visit a cell twice? You can. Okay guys, I don't know. Any idea? I do not have any idea. N is 50. Why is it N50? No man, I don't think I know. We can have states as R1 C1 R2 C2. Okay, yeah, we can, but how do we compute it? If the two paths intersect, the Manhattan distance of that cell and top left cell will be same for both. Really? Yeah, I think we should do some kind of observation. It's definitely some kind of observation. And then DP using that observation, but I can't come up with the proper observation here. Interesting. Yeah, but we need the number of empty cell, cherry, and blocked. We find some path, and then we can find another one. Can we take the optimal path, remove the cherries, and then find the other optimal one for returning? I don't think that's gonna be optimal though. I can do that. Find the maximum first path, remove the cherries, find the maximum second path again. But this doesn't guarantee me that the whole path is optimal, right? Don't think it does. Yeah, it's probably some DP, but I don't know. I don't know, guys. Any other idea? Nope. Nobody has ideas. All right. row 1, column 1. Alright, then I guess that's it. Here's what you're gonna do. I'm gonna exit the session, so I failed the interview, and I'm gonna see what the problem was, and I'm gonna take a look at the solution. Because this is what you should always do when you don't know how to solve problems, man. Just absolve it. Look at this. Greedy, wrong answer. Haha, I knew it. So yeah, the greedy approach was that to find the first optimal path and then remove the cherries, find the second optimal path. This is not gonna guarantee us that that this is optimal. All right, big O of n squared, yada yada. Dynamic programming, top down, accepted. So dynamic programming, intuition. Instead of walking from end to beginning, let's reverse the second leg of the path. So we are only considering two paths from the beginning to the end. Yeah, makes sense. It's the same thing. So start end plus end start is the same as start end and another start end. Makes sense. After t steps, each position row C, RC could be is on the line R plus C equals T. Is on the line. Is on the line. Oh, line means I think diagonal or something. So if we have two people at positions R1 C1 and R2 C2, then R2 equals R1 plus C1 minus C2. That means the variables R1 uniquely determine two people who have worked the same. No, dude. No, dude. No, dude. You either know this problem or you have no chance of solving an interview with that. Yeah. I'm sorry, guys. That's the broken part of coding interviews. That is the broken part of coding interviews. Yeah, I mean, if you're probably a genius, which I'm not, you are going to come up with a solution, but no. You either have solved this problem before or you won't solve it in an interview. So I recommend you take a look at the solution. I don't have the time because I have to go. I have to meet someone. But yeah, it's this nasty observation that after t steps, if we have two people, so if after t steps with one path I am in R1 C1 and with the other I am in R2 C2, then we know for sure that R2 is R1 plus C1 minus C2, and that uniquely, yeah, no, I'm gonna maybe do it later, not now. That's definitely not a good thing. Hey guys, so hope you enjoyed it. Hope you enjoyed the first two problems. I don't think I'm gonna make lives where I mock interviews anymore because the problem are too simple. So in the previous one, the two problems were simple. I solved them pretty quick. The second one was a little bit nastier on the statement, and the third one is hard. So let's say it's worth it to solve only the hard problem for from a mocking interview. So I think Leetcode mocking interviews are worth it, only if you want to practice the coding and stuff like that. But once you get to some level, if you are a beginner and totally starting with them, then they are fine. If you reach some level, then they are not worth it, not that much worth it. The two problems will be too easy, and the third one will be the one that's worth it, or it would be something super hard like that one. And yeah, solve problems on Leetcode, solve the hard ones, and upsolve everything you don't know how to solve. So I'm gonna take a look at this solution when I come back, and I don't know, maybe if it's worth it I'm gonna make a video about it, but I don't think so. Doesn't look like it's worth it. So yeah, hope you enjoyed it, guys, and I see you on the next one. Bye.